These are the word problems for the 1.6 radical equations. So let's go through some of these word problems. I think you'll find that they're very good examples and are pretty good sample questions of what you might see in your homework. Okay. All right, number 12 here. Kleber's law gives a relationship between an animal's metabolic rate, MR, and its body mass, M. Okay, so an important thing to notice about these word problems is that we need to know what each of these variables stand for. They tell us that MR stands for an animal's metabolic rate. So every time we see MR, we know that stands for the metabolic rate, and body mass, M. So every time we see an M, we know that's the animal's body mass, which is, I think, kind of like weight. Probably a scientist wouldn't like me saying that, but how much it weighs. MR is the metabolic rate, and M is the mass. All right, where MR is measured in kilocalories per day, and M is weight in kilograms. Okay, so as we read these problems, if they give us a measurement that's in kilograms, we need to know that's going to go in for weight. And every time they give us a measurement that's measured in kilocalories, we need to know that that number is going to go for metabolic rate. Okay. All right, so part A here. Find the metabolic rate of a lab mouse weighing 0.2 kilograms, which is about twice the mass of a pencil, and we're round to the nearest whole unit. Okay, so we need to know that this weight, 0.02 kilograms, that's a mass. We're going to put 0.02 in the place of M. And we are finding, it says find the metabolic rate. We are going to find MR. They are not telling us MR, that's what we're finding. So we're going to go to our equation. MR equals 73.3 M to the 3/4. They're telling us what number to put for M, and we're finding the MR. So MR is 73.3 times M. They told us M is 0.02 raised to the 3/4. I'm just going to type this in my calculator, and whatever comes out is going to equal the MR number. All right, so 73.3 times 0.02, I'm putting that in parentheses, raised to the 3/4. Okay, and we get 3.89. All right, so MR equals 3.8983, blah, 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 blah. Now, notice they told us to round to the nearest whole unit. That's like the nearest whole number. So we're going to round to the nearest whole number. 3 is in the whole number position. We look at the number to the right, first decimal here, to decide if that 3 needs to go up or stay. Rounding rules say if it's 5 or higher, we round up. So this is going to round up to 4. If we round to the nearest whole number, it'll be 4. I'm putting a little squiggly equals to say it's not exactly 4, it's rounded to 4. Okay? And then we need to probably put some units. I think your Connect Math program may want you to pick the unit in a drop-down menu. Remember, we just found MR, and they told us MR is measured in kilocalories per day. So even if you don't understand what those units or this problem is about, we can still plug in the right numbers and get an answer to come out. Okay? So a lab mouse, a tiny little mouse, weighs very, very little, will have a metabolic rate of about 4 kilocalories per day. Metabolism has to do with how fast you burn the food you eat. So it's a little bitty guy. He's going to have a very small metabolic rate. He's not going to burn calories very fast. All right, part B, same idea, only this time instead of a mouse, it's an elephant. The elephant weighs 3,000 kilograms, which is about 1 Ford Taurus car size, round to the nearest whole unit. So MR equals 73.3 times 3,000 to the 3/4. Typing that in my calculator. And I get this number. It's big. 29712.8914, a big old number. Again, round to the nearest whole number. So to the nearest whole number, 2 is in my whole number position. The first decimal is 5 or higher, so it's going to send it up. So it's approximately 29,713 kilocalories per day. Which makes sense. If you have a big old elephant, it's going to burn a whole lot of calories in a day. Okay, 29,000 of them. One word of caution, if you're using TI-83s versus a TI-84, in the TI-84, when I told it to do an exponent, it knew that entire 3/4 was the exponent. If you're using an 83, you're going to need to put, it won't make the 3/4 small up there in the exponent position. It's going to type a little caret symbol, so make sure that you're putting your 3/4 in parentheses, because a TI-83 will think you just want the exponent to be a 3. So you've got to put your 3/4 in parentheses if you're using a TI-83 for it to know that you want that whole 3/4 to be the exponent. Okay, part C here. What's the mass of a house cat that has a metabolic rate of 245 kilocalories per day, round to the nearest unit? Okay, so notice what's different here. They are not giving us the weight of the cat. They ask us for the mass of the house cat. We're finding the weight. We're finding M. What they're giving us, the 245, is the MR, is the metabolic rate. Okay, so that's a difference. It's the same equation, same formula, but this 245 is not the mass. This 245 is the metabolic rate. So I'm going to put my 245 over on the other side. And I'm solving for M. So this is where we have to kind of go back to what we did in the first part, our previous video, where we're solving for M. Remember, even though this doesn't have a radical, raising something to the 3/4 is a radical equation. So we need to isolate the radical. We need to get rid of the 73.3. So 245 divided by 73.3 is a terrible, horrible number. Okay, now I'm going to show you a little calculator trick here. I'm going to write down the first few digits of this number. I'm not going to write the whole thing because it's long and terrible. So I'm just going to write the first few numbers. But I want to leave the last line in my calculator as that whole decimal. I want my calculator to continue working with that whole number, not just the rounded off version. We do not want to do our rounding until the very end. Okay? All right. So now I need to... I have two options here. I can raise it to the reciprocal, which is 4/3, or I can think about this as a radical. So I can think about this as m to the 3rd, and then take the 4th root of it. Okay? So if I think of it this way, I need to raise it to the 4th to get the radical to come off and have m to the 3rd by itself. Okay? So in my calculator, instead of retyping these first few numbers, I'm just going to hit arrow, or the caret right here, to the 4th. Now notice what happened. As soon as I hit the caret, it said, oh, you want me to take that last answer and raise it to the 4th. What it's doing is using the entire number, so I don't have to retype it. All right, so 3.34 whatever raised to the 4th is 124.8097 blah, blah, blah. Again, I'm only going to write down the first few digits, but I want my calculator to remember that whole thing. Now to get m by itself, opposite of raising it to the 3rd is taking the cubed root. Okay, so I want to take the cubed root of that number. So I'm going to hit 3, math, pick option 5 to take the cubed root, and then I either need to retype this whole thing, which you'll probably have to retype if you're using an 83. But if you're using an 84, watch this. I can just arrow up. Okay, and do you notice, it's kind of hard to see, but it's highlighting that whole 124 number. So when I press enter, it pastes it back down there for me. If you're using an 84, you can arrow up and basically cut and paste. If you're using an 83, you'll probably have to retype that whole 124 number. Okay? All right, so my M is about 4.99746, blah, 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 blah. They told me to round to the nearest unit. That means round to the nearest whole number. Wait till the very end. Do not round on each step as you go. Wait till the end to do your rounding. And when we round to the nearest whole number, we would get 5. Okay? So this house cat weighs approximately 5 kilograms. And I know it's kilograms because in the original they told me that M was always in kilograms. Okay, right here. Okay, number 13. If an object is dropped from a height of h meters, the velocity, which is kind of like speed, in meters per second at impact is given by this equation right here. where G is 9.8 meters per second squared. G is for gravity, okay? So gravity affects how fast stuff will fall. Determine the impact velocity for an object dropped from a height of 10 meters. Okay, so notice H is always height in meters. G is always going to be 9.8 for our problem here. That tells G is always 9.8. And V is velocity, which is like speed. So part A, determine the impact velocity for an object dropped from a height of 10 meters. They're telling us to put 10 in the place of H. And determine the velocity. That means find V. We're finding V when we know the other stuff. All right, so V equals square root of 2 times G. They told us G is always 9.8 times H, and they told us H is 10. So I can just type this in my calculator, and it will tell me exactly what V is. So square root of 2 times 9.8 times 10. If you're using an 84, you can just type it like I did. If you're using an 83, when you hit that radical, it probably popped up a parentheses before your 2, so just make sure to close it at the end. And that comes out to 14. Now, what about the units? Well, velocity, they always told us, is in meters per second. So our answer will be 14 meters per second. That's how fast it would be falling. Part B, determine the height required for an object to have an impact velocity of 26.8 meters per second. Okay, so they're giving us the velocity. 26.8 is going to be the V. And we are determining the height. We are trying to find H. Round to the nearest tenth of a meter. All right, so we're still using the same equation. Okay. But this time they told us V. They told us V is 26.8. We know that the 2 is going to stay. We know that the G is 9.8 because it's always 9.8. And they told us to determine the height. That means we don't know what H is, but that's what we're trying to find. That's what they're asking us to solve for. Okay. All right. So first thing I would do, since I'm 2 times 9.8, that's something I can work out. So 2 times 9.8. Let's just, instead of leaving it as 2 times 9.8, let's just call that 19.6. That will be one less number we have to worry about. Okay, and we're solving this equation for H. So this equation will be a lot easier to deal with if that radical weren't there. So remember that it's got a square root. We would need to cancel the square root. To get rid of a square root, you square. Squaring and square rooting are opposites or inverses. So if I square the right, I better square the left. So 26.8 squared is a big number here, 718.24. But the radical is now gone, canceled with the squaring there, equals 19.6H. And now we just solve for H. So we divide by 19.6. Now notice my little trick here. My 718.24 is still there. So if I just hit divide by, it will know that I want to take that last number, the 718.24, and divide by 19.6. I don't have to retype the 718. Okay, and I get 36.644, blah, 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 is H. And now at the very end is when I'll finally round. They said round to the nearest tenth of a meter. So we need to know what number's in the tenths place. This 6 right here is in the tenths place. So that means I have to keep the 36 point, and I just need to decide if this 6 is going to go up or stay. Since the number after it is less than 5, that 6 is going to stay. So 36.6, what kind of units? Well, we're doing H. They told us H is always measured in meters. Okay, H is the height in meters. So 36.6 meters is our answer. Now, notice what we're saying here. If an object is moving at 26.8 meters per second, that's how fast it's falling, which is fast, by the way. It says that's approximately 60 miles per hour. So if something is falling at a speed of 60 miles per hour, by the time it hits the ground, it must have fallen from a height of 36.6 meters. That's what this is saying. Next example here, I really like this one. The yearly depreciation rate for a certain vehicle is modeled by this equation. Okay, now let's talk about what that word depreciation means. Depreciation means the value of something is going down. Depreciate means something is going down. Appreciate means something's value is going up. So things like homes and investments hopefully appreciate. They go up in value. Depreciate means it goes down in value. And if you think about it, a vehicle, a car that you buy, probably goes down in value as time goes by. When you first buy it, it's worth a lot. It's real expensive. As time goes by, its value goes down. It's worth less and less and less money. Okay? All right, so the depreciation rate, R stands for rate, is found by this equation right here. Okay, now I would point out R is rate as a decimal. So for example, if the rate is 8%, usually we talk about rates as a percentage, but we can't put percentages in equations. Okay, so if you want the rate to be 8%, you're going to have to call that decimal 0.08. So even though we may talk about rates as percentages, in the formula, the rate's always going to be a decimal. Okay? All right. V, it says, is the value of the car after N years. Okay, so N is years. How many years have you owned it? 2 years, 5 years, whatever. V is the value at that point in time. So V is the value after 2 years, after 5 years, after 8 years. Okay? And C is the original cost. So in this equation, C is the original cost. How much did you pay initially? $20,000, $30,000, whatever. Okay? All right. Part A, determine the depreciation rate. Okay, so they want us to find R for a certain car that originally cost $18,000. Okay, we said original cost was C. So we're going to put $18,000 for C. And is worth $12,000 after 3 years. Okay, so remember V is the value later. So $12,000 will be our V. 3 years, N was our time in years, so N is the 3. So they're telling us to put $18,000 for C, $12,000 for V, 3 for N. I like to label on my paper what each of those numbers stands for. And they want us to round to the 1/10 of a percent. Remember, we're finding R. Okay, so R equals 1 minus V over C raised to the 1 over N. And we're going to plug in our numbers. We said V was 12,000. We said C was 18,000. We said N was 3. So I plugged those numbers into the appropriate spot in my formula. I can type this in my calculator, and whatever comes out is R. I need to put parentheses around that 12,000 over 18,000. If you're using an 83, you'll need to put parentheses around your 1/3. If you're using an 84, you won't have to put parentheses around the 1/3. Okay, so R is 0.1264195, blah, 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 blah. Now remember, this comes out as a decimal, okay? But notice what they told me. They said round to the nearest 1/10 of a percent. Well, what is this number as a percent, okay? So this means as a percent, remember you moved the decimal twice. 8% was 0.08. We have the decimal, we need to go back to percent. So we move the decimal 2 places to the right. So 12.64195 blah, blah, blah percent. They want us to round to the nearest 1/10 of a percent. Once we have it in percent form, look at the tenths place. It's 6. The number after it is less than 5, so that 6 will stay where it is. It will not round up. It'll stay at 12.6%. Okay, this means that this car is depreciating or losing about 12.6% of its value every year. Okay. All right, part B, determine the original cost of a truck that has a yearly depreciation rate of 15%. Okay, so this is our R. They're giving us R. By the way, they gave it to us as a percent. When we type it in our formula, we're going to have to make it a decimal. So 15% as a decimal is 0.15. Okay, so our R is 0.15. It's worth $11,000 after 5 years. Okay, well, 5, that's our N, because N was always our time, the value after N years. And now we need to decide, is this 11,000, is it going to go in for V or C? Okay, well, remember C was the original cost, and V is the value later on. So is this 11,000 the original or the value later on? It's the value later on. It says it's worth 11,000 after 5 years. So this is the value later. The value later was V. So that's going to be our V. They told us to determine the original cost. And original cost is C. So we're trying to find C. All right, so I'm going to go to my equation. R equals 1 minus V over C to the 1 over N. Plug in the numbers we know. We know that R is 0.15. V, we decided was 11,000. C, we don't know, so I'm going to leave that as C. C is what we're trying to find. Raised to the 1 over N, and we decided N was 5. So we plugged in all the numbers we know. We're trying to find C. Okay, remember when we solve radical equations that we have to isolate the radical. I know you don't see a radical, but 1/5 here means this part is the radical. Okay, remember fraction exponents are like radicals. All right, so I need to get rid of this 1 and to isolate this part. So I'm going to subtract 1 on both sides. 0.15 minus 1 is negative 0.85. Equals negative symbol, 11,000 over C to the 1/5. I also need to get rid of this negative, okay? Even though you don't see a 1, this means negative 1 times this stuff. So if I want to get rid of the negative 1 in front, negative 1 is being multiplied by this stuff, so to undo it I can divide by negative 1. So negative 0.85 divided by negative 1 is positive 0.85. So positive 0.85 equals 11,000 over C to the 1/5. Okay. Now I need to get rid of this 1/5. Now if you want to, you could think about this as 0.85 to the 11,000 over C raised to the 1 with an index number of 5. Remember what the butt goes in the crack. So this is raised to the 1/5 power, or you're taking the 5th root. The exponent is 1. We don't have to write an exponent of 1. It's implied. Okay, so if I'm trying to undo the 5th root, that means I need to raise it to the 5th power. So I need to raise both sides to the 5th power. If you had just raised this from the very beginning to the 5th, that would have been okay. Power to a power, you still would have gotten the same thing. All right, so I need 0.85 raised to the 5th, which is a terrible, horrible decimal. Okay? Again, I'm just going to write the first few digits. Okay? We'll let the calculator remember that in just a second. Equals, and then this 5th root and raised to the 5th cancels out and leaves 11,000 over C. Okay? All right, so that's what we're left with. Okay, now we need to get C alone. The problem we run into here is even if I get rid of the 11,000, C is on the bottom. We don't want C to be on the bottom. We want C on the main line. So here's what I'm going to do. I'm going to multiply both sides by C. What that will do is leave 0.443705 blah, 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 blah. C equals 11,000. C is now out of the denominator and on the main line. Now I can get C by itself, okay? If I had gotten rid of the 11,000, C would have still been on the bottom, and that's not good. We need C on the main line on the top. Okay, so now C is being multiplied by this horrible decimal to equal 11,000. How do we undo this so that C can be by itself? Well, C is being multiplied by this decimal. We can divide by that decimal. So we're going to divide both sides by that decimal. And we're left with 11,000 divided by this thing. Okay, so 11,000 divided by, and I want to divide by that decimal right there, the 0.443. If you're using an 84, I can, after I type my 11,000 divided by, I can arrow up. It's highlighting that number, so I press enter and it copies and pastes it right there. If you're using an 83, you may have to retype that whole decimal. Make sure you type the whole decimal, don't round it off. Okay, so our C value is 24791.22898. Okay, what does that mean? Remember, C is our original cost. So cost of a vehicle is in dollars. It's money. So this means it's $24,791.22, whatever, okay? Probably, if money, you only round to the hundredths place, so this would be in 23 cents, okay? But if you'll notice, they told us to round to the nearest $100. I highly doubt when you bought a car you paid $24,791.22. They usually don't, round it to pennies like that. They usually round to maybe $100 or $1,000, whatever. So in the hundreds place is the 7 ones place, the tens place, and the hundreds place. So to the nearest $100, this would round to 24,800, because this is closer to 24,800 than it is to 24,700. So the cost of this vehicle originally must have been $24,800. Now, of course, according to our problem here, now it's worth $11,000. So it's lost quite a bit of value. When you bought it, it was $24,800. Now it's $11,000 because it's lost 15% value every year for those 5 years. Next example, the distance D in miles. So we know that everywhere there's a D, that stands for miles, that an observer can see on a clear day is approximated by this equation, where h is the height of the observer in feet. Okay, so h is the height in feet. D is the distance in miles. Okay, so here's what that's saying. If you are just standing like in your front yard, you can see a little ways down the road. But if you were, in the top of a skyscraper, 20, 30 stories in the air, you could see a lot further. The distance you could see would be a lot further because your h is a much bigger number. You're higher in the air. Okay? All right, so that's what they're having us examine here. They say Rita can see 24.2 miles. How far above the ground is her eye level? Okay, so how high in the air is she? So she can see 24.2 miles. They've given us miles. That's our distance. That's the distance she can see. So 24.2 miles is going to go in for D. And we want to know how far above the ground is her eye level. We're trying to find H. All right. So we're going to recopy this equation, but we're going to put 24.2 for D. 24.2 equals 55 over 50 times square root of H. H is what we're finding. Okay? All right, so I need to solve this equation. I need to isolate the radical part, so I need to get rid of the 55 over 50. Since 55 over 50 is being multiplied by square root of H, I can divide by 55 over 50. If I divide the right, I better divide the left. 55 over 50. In my calculator, I can type 24.2 divided by. Now notice, I need to type the 55 over 50 in parentheses. I want 24.2 to get divided by this whole fraction, so I need to indicate that 55 over 50 is its own number by putting parentheses around it. Okay? And I get 22. If you leave those parentheses off, you will get something different. You need to put parentheses to indicate that 55 over 50 is the actual value you're dividing by. Okay? All right, so 22, running out of room here, arrow over. So 22 is square root of H. Now we need to undo the square root. Opposite of square rooting is squaring. So I need to square that 22. I can just type answer squared, 484. That means Rita is 484 feet. It told us our units was feet above ground. And that's pretty high in the air, right? She's probably several stories up in the air. When she's that many stories in the air, she can see a long way. She could see 24.2 miles in the distance. Last one here, the equation R equals cubed root 3v over 4 pi gives the radius R, so R stands for radius, of a sphere of volume V. All right, so we know R is radius. We know V is volume. If the radius of a sphere is 3 inches, so that 3 inches, that's a radius, that's going to go for R, find the volume. They want us to find V. Okay? Now, notice it says find exact volume. More on that in just a second. Okay? Be sure to include the correct unit in your answer. Okay, so we know, here's our formula, we know R is going to be 3. So put 3 in for R. And we're finding V. We're solving for V. Okay, this little symbol right here next to the 4, that's a pi symbol. Pi is approximately 3.14 blah, 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 okay? They told us to find the exact volume. That means we cannot round off pi. We cannot call it 3.14. We have to leave pi in our problem. Leave that full value. Leave the pi symbol in there, okay? So even though we know pi is approximately 3.14, we're going to leave the pi symbol in all of our work. All right, solving for v. Pi is a number, it's not a variable. All right, we're solving for v here. So I need to get rid of this radical, so I'm going to cube both sides. 3 to the third is 27. 27 equals 3v over 4 pi. I'm leaving pi in there. Now I need to solve for v, so that means I need to get rid of the denominator. I need to get rid of 4 pi. I'm going to multiply 4 pi on both sides. 27 times 4 pi, and I'm just going to type 4 because I'm going to leave the pi there. Okay, so 27 times 4 pi is 108 pi. The pi is still there because I didn't round it off to 3.14. So 27 times 4 is 108, but the pi is still there. So 108 pi equals 3v. Now to get v alone, we divide by 3. 108 and pi times pi, whatever that is getting divided by 3. So 108 divided by 3 is 36, and the pi is still there. So 36 pi equals v. If the radius is 3, the volume of the sphere is 36 pi. Now we need to say what kind of units that is. What did they tell us volume was measured in? Well, let's see. If the radius is in inches, then the volume is going to be inches. 36 pi inches cubed, because we measure volume in cubic units. All right, so hopefully those word problems are good examples for you and will help you on your homework. Thanks.